Assalamualaikum warahmatullahi wabarakatuh. In lesson 9 class, we will talk about the anti-differentiation. Ang anti-differentiation class is just the inverse of the differentiation or inverse ng derivative. Anti-derivative, anti-differentiation, or integration is pare-parehas lang yon. So, dito sa anti-differentiation class, ito yung inverse ng derivative sa derivative of a function. So, di ba sa derivative class, ang process doon is always tayong magmaminus ng 1 sa exponent. But here in the anti-differentiation class, baliktad kasi always tayong mag-a-add ng 1 sa exponent. Tapos, yung in-add natin doon sa exponent, after tayong mag-add ng 1 sa exponent is ibababa natin siya or bring down natin siya sa denominator natin. Tapos, kung may constant man before the variable is remain lang siya or fix yung constant na yon. Saka na natin siya i-multiply pag magsisimplify na tayo. Okay, so let's start. So, sa definition 9.1.1, a function f is antiderivative of the function f on an interval I if f prime of x, capital letter f prime of x is equal to f of x for every value of x in interval I. For example, class, sa letter A, an antiderivative of f of x equals to 6x squared plus 4x is, okay, paghahanapin natin class is yung antiderivative na mention ko dun sa first slide na ang antiderivative or anti-differentiation is the inverse process of derivative or inverse process of differentiation. So, kung ang tinanong sa inyo, what is the antiderivative of this given function? To get the antiderivative, kailangan ang isulat ninyo is in capital letter F, f of x. Kung ang ginamit dito na variable is variable g, of course, capital letter G of x din yung isusulat ninyo dito. So, to get the antiderivative of this function class, ang gagawin lang natin is isa-isahin natin bawat term. So, sa first term, we have 6x squared. So, ang antiderivative ni 6x squared is, may constant tayo dito na 6. So, remain natin si 6 as constant. And then, yung variable natin na x, di ba may exponent siya na 2? So, mag-a-add tayo ng 1 sa exponent natin. So, naging 2 plus 1. Si 2 is galing dito. And then, after ninyong mag-add dito ng 1 sa exponent, yung nakasulat na dito or bagong exponent na ninyo is i-bring down natin sa denominator natin. So, eto, galing siya dito sa exponent. Okay, sa second term natin, si 4x, so we have 4. And then, si x, di ba may exponent yan na 1? Okay? And then, mag-a-add din tayo ng 1 sa exponent natin. Okay, so we have 1 plus 1. Tapos, after tayong mag-add ng 1 sa exponent, i-bring down natin siya sa denominator natin. And then, mag-a-add tayo dito sa last ng constant, capital letter C. Okay, so we have capital letter f of x is equal to 6. X to the power of 2 plus 1 is 3. And then sa denominator is 3 din yan. Okay, sa second term, we have 4. X to the power of 1 plus 1 is 2. Sa denominator is 2. So, we have plus the capital letter constant C. So, ito yung capital letter f of x natin. So, i-simplify natin siya class. So, magiging 6. And then, reciprocal ni 3 or i-times natin dito si 1/3. So, magiging 6 over 3 na yan. We have x to the power of 3 plus 4 over 2. X to the power of 2 plus the constant C. Or this is equal to 6 divided by 3 is 2. X to the power of 3 plus 4 divided by 2, x to the power of 2 plus the constant C. So this is the antiderivative of the given function f of x equals to 6x squared plus 4x. Kung i-check natin to class, if tama ba na yan talaga yung antiderivative niya, we can check that one by getting the derivative of this. Kasi diba inverse lang man sila. So yung final answer ninyo after ninyong kinuha yung antiderivative ng given na function, pwede ninyong ma-check if tama ba siya. I-check natin yung final answer, i-derive natin siya. Kung babalik siya dun sa original na function, which means tama yung nakuha natin na sagot. Okay, so let's check. So, di ba ang final answer natin is f of x equals to 2x cubed plus 2x squared plus the constant c. So, get the derivative of this. So, magiging f prime of x is equal to 2 times 3 is 6. X to the power of 2 na lang yan. Kasi di ba magmaminus tayo ng 1 sa exponent kapag derivative. Plus, 2 times 2 is 4. X, di ba? Plus, yung constant C natin. Okay. So, di ba bumalik tayo doon sa original natin na function? Ang original na given is 6x squared plus 4x. So, that's why, ang sabi doon sa definition, yung capital letter f prime of x is equal siya sa f of x. Yung capital letter f prime of x is eto siya. Tapos etong f of x na to is yan yung given natin. Okay, so that is for the first example. Let's give another example class. If ang given natin na f of x is equal to x to the power of 4 plus 2x cubed plus 3x squared plus 4x plus 1. So, find the antiderivative of the given function. So, ang antiderivative nito, take note, dapat it should be in capital letter f of x pag nag-antiderivative na kayo. So, we have sa first term natin class, ang x to the 4, di ba may 1 dito, understood na may 1 dyan. So, we have 1. Pwedeng din natin ilagay sa 1, which means diretso na tayong mag-add ng 1 sa exponent. So, we have 4 plus 1. Bring down natin sa denominator natin, si 4 plus 1. Plus, yung second term natin, we have 2. Tapos, x to the power of 3 plus 1 over 3 plus 1. And then, sa third term, we have 3. X to the power of 2 plus 1. Sa denominator is 2 plus 1. Sa fourth term, we have 4x to the power of 1 plus 1 over 1 plus 1. Okay. And then last, ang antiderivative ni 1 is, di ba, si 1 plus na term is, ang kasama niya na variable is x to the power of 0. Di ba? Kasi x to the power of 0 is just equal to 1 lang man. So, times 1, 1 pa rin. So, kung lalagyan natin yan, pag sa given ninyo class na function is may constant, if kukunin nyo na yung antiderivative niya, lagyan nyo lang siya, i-bring down nyo lang yung numerical value, tapos dagdagan nyo lang siya ng variable x. Kapag may constant na kasama sa function ninyo. Okay, bakit ko nilagyan to ng x? Kasi, di ba, kung ang mangyari dito is 1, x to the power of 0, mag-add tayo ng 1, di ba 0 plus 1, sa denominator is 0 plus 1 pa rin. So, 0 plus 1 is x to the power of 1, tapos sa denominator is 1. So, x to the power of 1 divided by 1 is x pa rin. So, that's why, ang technique is, if may constant sa function ninyo class, if you're going to get the antiderivative or the antidifferentiation of that term is lagyan nyo lang or dagdagan nyo lang siya ng variable na x kung x yung ginamit. Kung variable y din yung i-add ninyo. And then do not forget sa pinaka-last, i-add ninyo si capital letter C or the constant C. Okay, so i-simplify natin. So we have x to the power of 5 over 5. Okay, plus sa second term is magiging 2x to the power of 4 over 4. Plus sa third term, we have 3x to the power of 3 over 3. Plus 4x to the power of 2 over 2. And then 1 times x is x plus the constant c. Or this is just equivalent class. Okay, yan yung capital letter f of x natin. So we have 1 over 5 x to the power of 5 plus 2 over 4. Okay, 2 over 4 or pwedeng 1 half kasi yun yung simplified form. X to the power 4 plus 3 divided by 3 is 1 na lang times x cube is x cube pa rin. Plus 4 divided by 2 is 2. X to the power of 2 plus x plus the constant c. So this is the antiderivative of this given function. So if you are going to check if tama ba yung sagot ninyo, you can get the derivative of this. So pag bumalik siya dito sa original na function, which means tama yung nakuha ninyo na antiderivative.
Other derivatives of f of x, ito yung sa example natin sa previous. F of x equals to 6x squared plus 4x or f sa 1 of x pwedeng 2x cube plus 2x squared plus 1. Kasi yung c na yun class, diba, ang sabi ko, every time na after kayong mag anti-differentiate or mag-integrate, always kang mag-add ng c. Etong c kasi class is any arbitrary constant. Ibig sabihin kahit ano yung value niyan. And also, pwede din natin masabi na ang antiderivative ni 6x squared plus 4x is ito. In fact, any function of the form 2x cubed plus 2x squared plus c, where c is a real number, is an antiderivative of f of x. So observe that f prime of x, okay, is equal to 6x squared plus 4x equals to f of x. So the same with letter B. If f is an antiderivative of f on an interval I, then every antiderivative of f on I is given by capital letter f of x plus c, where c is an arbitrary constant. So ito yung sinasabi ko na every time, right after kayong mag-antidifferentiate or mag-integrate is always my constant c sa last. Using the theorem above class, we can conclude that if f sub 1 and f sub 2 are antiderivatives of f, then f sub 2 of x is just equal to f sub 1 of x plus the constant c. That is, f sub 1 and f sub 2 differ only by a constant. So, tama, di ba? Kung titingnan natin dito sa example na to, magkaparehas lang talaga yung antiderivative nila, but dito lang sila nagkaiba sa constant. Okay, plus or minus 1, plus or minus 2, pwede yun. So, ito yung mga terminologies and notation sa antidifferentiation. So, antidifferentiation class is the process of finding the antiderivative. So, ibig sabihin nun, si antidifferentiation, parehas lang siya as the antiderivative. So, that is the inverse of the derivative. This symbol class, etong parang S, okay, is also called the integral sign. So, ito yung tinatawag na integral sign. Kasi dito sa integration or antidifferentiation, pag mag-discuss na tayo further is, sa calculus 2, ito na yung ginagamit natin na sign. Hindi na tayo gagamit ng function value na f of x, g of x. Kasi ito na yung gagamitin natin na sign. Ang tawag dito is the integral sign. Denotes the operation of antidifferentiation. The function f is called the integral. So, ang function f na to, yung function f na nakalagay dito right after the integral sign is ang tawag doon is yung integral. If f is an antiderivative of f, we write that the integral it is read as class as integral of f of x dx is equal to the capital letter f of x plus c. Ibig sabihin nito, ang antiderivative daw nito is, or antidifferentiation niya is si capital letter f of x plus c. Katulad nung diniscuss ko kanina sa previous slide. Okay, ang tawag dito class, si f of x, that is the integrand. Ang tawag dito sa sign na ito is yan yung integral sign. Take note, si symbol na integral sign at saka si dx is hindi yan pwedeng magkahiwalay. Kailangan always yung magkasama. Kung ang ginamit dito na variable is variable x, of course, dx din yung ilalagay dito. Right after ninyong isulat yung integrand ninyo. Kung variable y yung ginamit sa integrand, ibig sabihin dy din yung ilalagay ninyo dito. The symbols integral and dx go hand in hand, and dx help us identify the variable of integration. So that's why hindi pwedeng magkahiwalay si integrand at saka si dx. The expression capital letter f of x plus c is called the general antiderivative of f. Meanwhile, each antiderivative of f is called a particular antiderivative of f. Okay, so yan yung mga terminologies, important terminologies and notation. So, sa following discussion natin class, eto na yung gagamitin natin na symbol. Hindi na tayo gagamit ng capital letter f of x. Sa theorem 9.1.7, theorems on antidifferentiation class, we have 4 theorems on antidifferentiation. The first theorem is the integral of dx equals to x plus c. So pag nakita ninyo ito class, ang given is integral of dx, automatic na ang integral nito is x, or ang antiderivative ni dx is cx. Do not forget the constant c, capital letter C dapat, right after kayong nag-integrate or nag-anti-differentiate. In the second theorem class, if n is any real number and n is not equal to -1, then the integral of x to the power of n equals to x to the power of n plus 1 over n plus 1 plus the constant c. Eto, nagbigay na din ako ng example nito, yung video doon sa previous slide natin. Basta integrate ka na rather na, always ka no pag-add sa 1 sa exponent, na mapasad ka no mag-add sa 1 sa exponent na imbaba yung bugi to exponent yung waki-adden din sa 1 sa isa denominator yo. For the third theorem, if a is any constant and f is a function, then integral of a f of x dx equals to a times the integral of f of x dx. Ayabo pagning sa ikatalawa theorem na gaya a saya na constant na uaden ko na constant function siko o dinaan na constant siko integrand dio, kasi di ba ang tawag dito is the integrand, nagkapakanyo kung kanyan ilio and then ipag times yubo kung kanyan siko integrand dio. Okay, ibig sabihin nun na let's say for example integral of 2 dx na di ba since si 2 na constant mananan nagkapakaya ilius kanyan, tapos times the integral of dx. Okay. And then si 2 na ipag-times yung buko integral laya. So na integral dx from using the theorem, first theorem, integral of dx is x and then plus the constant c. For the last theorem sa antidifferentiation, if f and g are functions defined on the same interval, the integral of f of x plus or minus, pag magkaparehas si plus or minus, g of x dx is equal to the integral of f of x dx plus or minus the integral of g of x dx. So, ibig sabihin, boya class, na if ay a given tanod na integrand na polynomial function, lagi do inibigay na alternative example si ko previous slide so video ron na basta polynomial din, so given yung integrand na bawat term na punggagay sa anyo kuon, so integrand yan. Dito bu ipagmeaning sa giya ikapata theorem. Using the theorems on antidifferentiation, let's give an example. So determine the following antiderivatives or determine the following integration. the following integrals rather. So first, we have the given integral of 3 dx. So using theorem A and C of the theorems on anti-differentiation class, we have the integral of 3 dx. So 'di ba doon sa C, pag may constant daw tayo before sa integral natin class or kasama sa integral natin, pwede natin siyang ilabas sa integral sign. So we have 3, nilabas natin siya sa integral sign. And then integral of dx na lang. So we have 3, ito yung 3, and then integral of dx class from theorem A sa theorems on anti-differentiation is x. So ang integral nito is 3x plus c. Okay, si 3 na punsiyanan, ginan na x, na ginan so, integrally dx, ilayan nyo sa theorem A. Sa letter B, ang given natin is integral of x to the power of 6 rather, dx. So, pag ganito, pag variable tapos may exponent, to get the antiderivative or to integrate this one is just simply add 1 to the exponent. So, take note, pag nag-integrate na kayo, ibig sabihin nun, nag-add na kayo ng 1 sa exponent doon sa mga variables ninyo, tatanggalin na yung integral na sign at saka si dx. Ha? Pag andyan pa si integral sign at saka si dx, ibig sabihin nun, hindi pa kayo nag-add ng 1 sa exponent. So, we have x to the power of 6 plus 1. Diba wala ng integral sign dito? Okay, over 6 plus 1, then plus the constant c, or this is just equal to x raised to the power of 7 over 7 plus c. For the third example class, integral of 1 over x to the power of 6 dx. So, ang variable natin is nasa denominator. So, para mas madali natin siyang ma-integrate, ilagay natin siya sa taas. Kasi, pag nalagay na natin sa taas yung variable, pag walang denominator, di ba mas madali na natin siyang ma-integrate. Okay, yun yung gagawin natin. Kapag may constant sa taas, constant lang, tapos yung variable nasa denominator, tapos monomial, ilagay natin sa taas. So, magiging exponent ng variable natin dito is magiging negative. So, integral of 1 over x to the power of 6 dx is just equivalent to the integral of x to the power of negative 6. Ibarat muna yung matatago sa puro na 5 na sa baba na x to the power of 6 na para before nyo na ipag-integrate na kapakay nyo na isurat as integral of 5 kasi 5 is the constant man, no? X to the power of negative 6 dx. Okay, so kapag na i-integrate. Mas okay i-integrate pag walang denominator. Okay, so add tayo ng 1. So x to the power of 6 plus 1 divided by negative 6 plus 1. So we have plus the constant c. We have x to the power of negative 5 over the negative 5 plus c. Or ibalik natin sa original na dapat positive yung exponent. So, which means ito ilagay natin sa denominator. So, magiging negative 1 over 5, x to the power of 5 plus c. Okay, for the fourth example, ang given natin class is the integral of 4 square root of u du. Okay, using the theorem B and C, we have si 4, pwede natin siyang ilabas sa integral sign. So, we have integral of u to the power of 1/2 because square root of u is just equal to u to the power of 1/2 du. Okay, kapag ang given you din class is naka-radical sign, naka-radical expression siya, convert it into exponential katulad nito para mas madali natin siyang ma-integrate. Okay, tanong din nyo, ibarat po na lagi the example number 3. So, variable tanong na sa baba na ipanikyo ka para madaso denominator o na bunyubos kayo ni pag-integrate na basta man na given niyo na radical expression nun na i-convert yun daan into exponential para mas malubudius kanya na integrate. Okay. So, u to the power of 1/2 du. So, we have 4 times the integral of u to the power of 1/2 plus 1 over 1/2 plus 1. Kumbaga, nag-iya denominator yan na rubo kinuha sa exponent. Before ikaw sa surat sa number sa denominator, kailangan na niya ka-add kayo dyan sa 1 sa exponent yun. Okay, so we have 4. U to the power of 1/2 plus 1 is 3 halves. 3 halves din sa denominator. So, get the reciprocal of 3 halves. So, magiging 4 times yung reciprocal ni 3 halves na 2 over 3, di ba? Okay. Basta aayam itago sa denominator yun na fraction na before nyo kan ipag-times saya, si ko constant si A, nakuha nyo din, so reciprocal yan. So 4 times 2 is 8, so that's why 8 ito, and then over 3. U to the power of 3 halves plus C. Okay, so that is for the example number 4. And this is number 5 class ha. Okay, for number 5, ang given natin is the integral of 12x squared plus 2x dx. So, katulad nito is yung example doon sa video. Sa third slide ba yun? Third slide at saka fourth slide. Okay, so ito, kunin natin yung integral nito. Kukunin din natin yung integral ni 2x or anti-differentiation ni 2x. So, since si 12 constant, pwede natin siyang ilabas. We have the integral of x squared dx plus integral ni 2x dx. Nilabas muna si 2 dito. We have the integral of x dx na lang. Or pwede man na, diretso na kayong mag-add ng 1 sa exponent. So, we have 12. X to the power of 2 plus 1 is 3. Sa denominator is also 3. And then 2 raised to the x raised to the power of 1 plus 1. 2x squared na siya over 2. So we have 12 divided by 3 is 4, x cubed, 2 divided by 2 is 1, x squared plus c. Kapag class sa dinyod na ya ay follow-up process, kapag diretso ka nun, but nagigiven na diretso ka nun mag-add sa exponents, mag-add ng 1 sa exponent. For number 6 class na example, using theorem B, C, and D, we have t times 2t minus 3 square root of t dt. Ito na ito pitaruakan basta an radical expressions ko given niyo na i-express you daan or transform you daan into exponential form, katest kanyan. Tapos, take note, before ka na pag-integrate na, simplifyan nyo din, so given nyo integrand. Gipag min na integrand o mga given sa integrand daya, integrand nanan, ginan integrand nanan, ginan ma-integrand nanan. Okay, ginan ni ma-integrand. Since na tita no siya, ibig sabihin nun na i-distribute na din siya. So, t times 2t is 2t squared. T times 3 squared of 3 squared of t is magiging 3. T to the power of 3 halves because square root of t is 1 half. T to the power of 1 half, diba? So, 1 half plus 1, that is 3 halves. So, equals to 2 times the integral of okay. So, ang integral nito, pwedeng diretso na din tayong mag-add ng 1. Pwedeng wala na tong part na to. Okay, so 2t to the power of 2 plus 1 is 2 to the power of 3, diba? Over 3. And then minus 3 to the power of 3 halves plus 1 is 5 over 2. Sa denominator is also 5 over 2. So we have 2/3 t to the power of 3 minus 6 over 5 t raised to the power of 5 over 2 plus c. For the last example sa anti-differentiation using theorems A, B, and D, so we have the integral of x squared plus 1 over x dx. So, para ma-eliminate yung denominator, okay? So, ano yung gagawin natin dito? Pwede natin itong i-simplify since monomial man yung sa denominator natin. So, we have x squared divided by x squared is 1. Tapos, 1 over x squared is 1 over x squared is equal to x to the power of negative 2. Gaya class na, yasuanan na x squared, i-divide kas kayan sa x squared, diba? Basta monomial, so divisor tano, plus, so second term man na 1 over x squared. Okay. So, diba x squared divided by x squared na equals to 1. Na 1 over x squared, na lagi do example tano saya sa number 3 ay inipanis kayan sa puro, that's why naging x to the power of negative 2. So, kung integrate natin to, ano yung sinabi ko doon sa previous video, kapag may constant kayo sa given ninyo na function or sa integrand, na pagumanan nyo sa kanyang sa variable x. Kung variable x yung ginamit. So, since variable x, si 1, ang integral ni 1 is x na lang. And then, integral ni x to the power of negative 2 is negative 2 plus 1 is negative 1. So, that's why negative 1 sa exponent, negative 1 din yung sa denominator. So, this is the integral of the number 7. So, ito yung mga examples for the following antiderivatives. Chain rule for antidifferentiation. Let G be a differentiable function of X and let the interval I be the image of G, and let F be a function defined on I and F be an antiderivative of F on interval I. If we let U equals to G of X, then the integral of F of G of X times the G prime of X. Itong G prime of X na to class, ito yung derivative ni G of X dx is equal to the integral of f of u. Okay, naging f of u siya because we let G of X as our u. And then, gaya G prime of X dx saya, naginan so, derivative G of X. So, yan yung equivalent ni du. Okay. So, that is equal to f of capital letter F of u. Pag nag-integrate na tayo, di ba, magiging capital letter F na yung ginamit natin doon sa first slide natin, class. If kukunin natin yung antiderivative. Capital letter F of u plus c is equal to the capital letter F of g of x. We replace u by g of x plus the constant c. So we have a corollary here. The integral of u of x raised to the power of n times the u prime of x dx is equal to u of x to the power of n plus 1 over n plus 1 plus the constant c where n is not equal to negative 1. For example, class, evaluate the integral of x times the cube root of 1 plus 2x squared dx. So this time, hindi na natin dito ma-apply yung usual na anti-differentiation, yung process ng anti-differentiation, yung mag-add lang ng 1 sa exponent. Kasi, di ba, si Gia, may transform tayo nuwaya into exponential form na di ka pa kayo manadire-diretso tano mag-add saya sa exponent sa mag-add sa 1 sa exponent. So, ang gagamitin natin ito, class, pag hindi siya magamitan ng usual anti-differentiation is yung chain rule. Okay, chain rule yung gagamitin natin. Okay, eto class, etong given natin, pwede yung ma-rewrite as or ma-express as x times 1 plus 2, x to the power of 2. Okay? So, di ba ang exponent natin dito sa love is 1? So, 1 yung ilalagay natin sa numerator ng exponent. And then, yung index natin is 3. So, siya yung ilalagay natin sa denominator ng exponent natin. Tapos, dx. Take note, reminder lang, class, pag may radical expression sa given natin na integrand, always transform it into exponential form. Okay. So, di ba, gini na di tanuyag ka pa kay distribute to x saya, kasi na exponent saya na ba 1? O ay exponent saya na 1, nagkapa kaya i-diretso tayo distribute saya so x sa sulit. Since nabas kayo equals to 1, ibig sabihin na di saya i-apply so usual anti-differentiation. Ay, kasway ni nakusar tano ron si chain rule. Pag let tano saya sa variable u. Okay, kadibag ito manipitero saya sa theorem. Okay, ang i-let din natin na u class, make it sure na ayan yung ipag-let u na so ilayan nyo so given yung andi pinakamalawon ana term mo na malawon ni exponent. Tapos make it sure na so gito ipag-let u na so derivative yan nasisibo mambusag given tano. So let's say for instance, ang lilet natin dito na u is si 1 plus 2x squared. Okay, let u equals to 1 plus 2x squared. Giniya si sa sulod parenthesis. Isa pa na hint sa chain rule class na so, matatago sa sulod parenthesis igira. Pero na ba all the time na gito'y always ay pagleta u. Ibarat buwan na exponent yan mambusaya na ba equal to 1. Na gito'y always ay pagleta u. Tapos, after ninyong mag-let ng u, derive nyo lang siya both sides. So, ang derivative ni u is si du. Nag-add lang kayo ng variable d. Ibig sabihin nito, derivative ni u. And then, ang derivative ni 1 plus 2x squared class is si 4x, di ba? Derivative ni 1 is 0. Derivative ni 2x squared is 2 times 2, that is 4, di ba? and then x, 2 minus 1 is 1, x to the power of 1 na lang. And then after ninyong mag-derive sa right side, always kayong mag-a-add dito na dx. Gito'y pattern niyan. Mag-let ka no sa u na si both sides na ipag-derive u na gini sa left side na pagumanan nyo bus kanyan sa du. Nasaya man bus sa right side man muna after ninyo ma-derive a function si a na always yung mambunan pagumanan sa dx. Okay, or equivalently 1/4 du over dx. Mag-derive, this is x dx. May variable x dito. Okay, divide it both sides rather by 4. Okay, di ba ang mangyayari is du over 4 na lang or 1/4 du equals to x dx. Then, ito yung original natin na function na transform. Pwede natin i-transform muna. Okay, so we have the integral of giya si x saya na siya kang pasityago sa oriyan para makapagpada si x dx kapara misambiyon class na sige niya para misambiyon na giya si 1/4 du. Ana x saya kaya kurangan boya sa x. Okay, para misambi ki x dx na si 1/4 du. Pag-substitute ta na ron nagini man buak cube root of 1 plus 2x squared na cube root pa rin nanan. Tapos, awaray minis, di ba, transform man na, Ay, yes1 na si x, wait lang, 1 plus 2x squared, quantity 1/3, di ba? Nanimyaswa yan, na si x. Okay, gaya x saya na iuman na kan saya ki dx, yan ipapagpadanakan. Nagimyaswa yan, naginya sa sulad, agiya sa sulda parenthesis na sembiyan yubunan sa u, kasi na, di ba, giya sembiyan, ginanigilet tanwa u, nambulis ka na u to the power of 1/3 times si x dx man na ayaran minisambi na si ginia 1/4 du. So, factor out tanu si 1/4, we have the integral of u to the power of 1/3 du. So, 1/4, ang integral ni u to the power of 1/3 is mag-add lang tayo ng 1 sa exponent. So, 1/3 plus 1 is 4 over 3. Bring down lang sa denominator. And then, 1/4 times 3 over 4 is 3 over 16. Yung reciprocal nito 1/4 times 3 over 4. That's why naging 3 over 16. And then, kailangan class, sa final answer, ibalik ninyo yung original function. Di ba, ayata nugilet tayo na si 1 plus 2x squared, which means, nag-i-ayu si A, nakisambiyo na si 1 plus 2x squared. Ginan sa original na given, so exponent yan na mimbaloya 4 over 3 plus C.
For example, integral of 4 plus 7x cube dx. Okay, so di ba pag nakita natin to, ang unang maiisip natin is, expand natin to. So, kukunin natin yung product niya. Okay, para hindi na tayo mag-expand, para maless na yung time sa pag-integrate is, pwede nating apply dito yung chain rule for anti-differentiation. So, sa chain rule for anti-differentiation, magle-let tayo always ng variable u. Okay, so, let u, so usually class, ay ipag-let tayo na, so matatago talaga sa parenthesis. And then, make it sure na, so ipag-let u ay u na, so derivative yan bumambu na, si saya budapat ng busag given. Kasi na goal agya chain rule na giya a function tano, giya integrand tano na kailangan na matransforma ng langon in terms of variable u. Okay, so let u is equal to 4 plus 7. Okay, so let natin yan Let u is equal to 4 plus 7x. Okay, so i-derive natin yan both sides. Ang derivative ni u is du. Okay, and then derivative ni 4, di ba 0 na yan? Kasi derivative of a constant function is 0. And then derivative of 7x is equal to 7. So since nag-derive tayo, add natin si dx. Every time na mag-derive tayo dito sa left side ng expression ng equation natin is kailangan may dx. So divide it both sides by 7 para si dx, ang maipalit natin dyan is si du over 7. Okay, so this is equal to du over 7. equals to dx. Okay, so pwede natin siyang matransform into in terms of variable u. So we have the integral of, eto siya si 4 plus 7x, replace natin yan by variable u, kasi di ba yan yung gilet natin kanina? Since remain lang natin si exponent na 3, so isusulat natin dyan si exponent na 3. And then si dx naman, ay isambitan no saan na si, di ba kataya si dx, na isambitan no saan mabuna si du over 7. So we have du over 7. Okay, so pwede nating i-factor out or ilabas yung constant. So, di ba pag walang nakalagay na numerical coefficient, understood na may 1 dito. So, ang numerical coefficient natin dito class is 1 over 7. So, ilabas natin si 1 over 7. So, we left with the integral of u cubed du. Okay, so since wala na siyang denominator, pwede na natin siyang ma-integrate. Ibig sabihin, mag-a-add na tayo ng 1 sa exponent. So, we have 1 over 7 times the integral. Okay, so this is not integral sign ha. U to the power of 4 na yan kasi 3 plus 1. Bring down lang natin sa denominator plus the constant c. Okay, so simplify natin. So, we have 1 times 1. 1 times 1 is equal to 1. 7 times 4, kasi whole number lang naman siya. So, 7 times 4, that is equal to 28. So, we have u to the power of 4 plus the constant c. Okay, take note. Kailangan, pag naka-variable u siya, in final answer, dapat ibalik natin siya in terms of variable x. So, magiging 1 over 28. Si u is i-replace natin by 4 plus 7x. Ang exponent natin dito class is 4. So, we have 4 plus the constant c. So, therefore, the integral of 4 plus 7x quantity cube dx is equal to 1 over 28 times 4 plus 7x quantity 4 plus c. Derivatives of functions yielding exponential functions and logarithmic functions. So, may module naman ako na na-provide. So, ibig sabihin, pwede nyo nang tingnan doon yung definition exponential function and logarithmic function. So, i-differentiate ko lang sa exponential function at saka si logarithmic function. So, ang exponential function is we can write exponential function, or we can express exponential function as y is equal to a raised to the power of x, while logarithmic function can express as x is equal to a raised to the power of a, because logarithmic function is just the inverse of the exponential function. Or etong expression na to, pwede natin siyang ma-rewrite as y is equal to the log of x to the base a. Y is equal to log of x to the base a.
Sa Theorem 9.2.1, in antiderivatives of functions yielding exponential and logarithmic functions, if a and b are any positive numbers, then the ln, or the natural logarithm of a times b, is equal to the natural logarithm of a plus the natural logarithm of, or the ln of a plus the ln of b. The second theorem is the ln of a divided by b is equal to the ln of a minus the ln of b. And then, the value of ln of 1 is equal to 0, and the ln of a raised to the power of r is just equal to r multiplied by the ln of a, where r is a rational number. So theorem 9.2 class, if x is positive, then the ln of x is just equal to the log of x with the base e. Or ito yung natural logarithm class. Na-discuss ko na to sa prelim coverage natin. This theorem states that the ln x, or read as ln of x, is the logarithm function to the base e, which is also called the natural logarithm, also Napierian logarithm. Logarithms to the base 10 are called common logarithms. So, review lang to kasi na-mention ko na to doon, or na-discuss ko na to doon sa prelim coverage natin. Sa theorem 9.3 class, exponential function x, or expx, is equal to e to the power of x for all x. Take note, the function f of x is equal to exp of x, and the function f of x is equal to e to the power of x. In this lesson, we will present the basic formulas for integrating functions that yield exponential and logarithmic functions. But let us recall first the following differentiation formulas. So, ang derivative class ng e to the power of x is parehas pa rin sa sarili niya, is equal to itself, that is e to the power of x pa rin. Ang derivative ng a to the power of x is equal to a to the power of x multiplied by the ln of a. And then the derivative of ln of x, take note of this kasi ito yung laging lumalabas. Ito, yung sa letter E at saka sa letter C. Derivative of e to the x is equal to e to the x. Derivative of ln of x equals to 1 over x. And then the log of u with the base a is equal to the ln of u over the ln of a. Because the antidifferentiation is the inverse operation of differentiation, the following theorem should be immediate.
So theorems on antiderivatives of functions yielding exponential functions and logarithmic functions. So the first theorem is the integral of e to the x dx is equal to e to the x plus c. So ibig sabihin nun, if ang given natin na integrand is e raised to the power of x, ang integral niya rather is e to the power of x plus c. And then the next one is the integral of a raised to the power of x dx is equal to a raised to the power of x over the ln of a plus c, where a here is not equal to 0. Okay, so hindi pwedeng maging 0 yung a natin dito. And then the third theorem is the integral of x to the negative 1 dx. So, ibig sabihin, special case ito, x to the power of negative 1 dx is equal to the integral of 1 over x dx. So, eto siya, the same lang dito or equal lang dito. Kaso nilagay lang siya sa denominator para maging positive yung exponent ni variable x natin. So, eto din siya, pwede natin siyang ma-rewrite or ma-express as the integral of dx over x because 1 times dx is just equal to dx, and then just copy the denominator x, and then the integral of this, kahit saan sa tatlong expression na to yung makita ninyo na given, ang integral niya is equal to the ln of x plus c. Okay, so tandaan nyo ha, kahit saan dito, basta if may base tayo tapos ang exponent niya is negative 1, pwede natin siyang ma-express na ganitong form at saka pwede natin siyang ma-express na ganitong form. So, ibig sabihin, ang integral niya is the ln of x plus constant c. Okay, another example sa theorem 1.2.2, ang given natin na integrand is 3 raised to the power of x plus 1. Okay, di ba doon sa theorem 1.2.2 na letter B is, ang exponent lang ni A dito is x, wala siyang kasamang ibang term. Okay, so dito sa letter C, meron na siyang kasamang ibang term, si 1. Okay, so ibig sabihin, eto siya, pwede natin siyang ma-simplify or ma-express as the integral of 3 to the power of x times 3 raised to the power of 1. Kasi 'di ba, sa laws of exponent, kapag parehas ng base, ang gagawin lang natin sa exponent nila is i-add kapag i-multiply natin 'yon. Okay, so eto, na-express siya as ganito. So ibig sabihin, eto siya, pwede na natin itong ma-integrate using the theorem 1.2.2b. And then, si 3 raised to the power of 1 is equal to 3. Kasi diba any number raised to the power of 1 is just equal to the base. Okay, so that's why etong 3 raised to the power of 1 na yan, nilagay siya dito sa labas ng integral sign natin. Kasi diba doon sa theorems on antidifferentiation, kapag may constant na before si function is pwede natin siyang ilabas sa integral sign. And then we left with 3 raised to the power of x dx na lang sa loob. And then, si 3 is as is lang yan. So, eto siya, class, eto, yung 3 raised to the power of x dx is ang integral niyan is naging 3 raised to the power of x over the ln of 3 using the theorem 1.2.2 B. Eto. Okay? Okay, another example. Letter D. Example letter D. The integral of 2 over x dx. Okay, so di ba sa theorem 1.2.2 letter C, ang meron lang tayo class is the integral of x to the power of negative 1 dx, or this is just equivalent to 1 over x dx. Okay, so 1 over x, ibig sabihin 1 yung constant sa numerator and then x yung variable sa denominator. So dito kasi sa example letter D natin, pwede natin ito, para ma-apply natin yung theorem C na yan sa 1.2.2 is i-express muna natin na katulad nito. Kailangan 1 lang yung exponent, numerator natin, tapos sa denominator is the variable x. So since si 2 is constant naman, so ang ginawa is finactor out muna si 2, nilagay dito, and then times 1 over x. Kasi di ba babalik din siya doon sa original natin na function. So 2 times 1, that is equal to 2. And then the denominator is x. So ibig sabihin, constant is 2. So nilagay siya dito sa labas, finactor out na siya. We left with 1 over x na lang sa loob ng integral sign natin. So ibig sabihin, etong expression na to, or etong term na to is, ang integral niya is the ln of x plus c. Okay, the ln of x plus c times the constant 2. Okay, so let's proceed to example 1.2.2. Examples doon or application doon sa theorem 1.2.2 na diniscuss ko sa previous video. Okay, so first example is the integral of e to the power of x plus 2 raised to the power of x dx. Okay, so 'di ba na mention ko na sa anti-differentiation, kapag mag-integrate tayo ng polynomial function, ang gagawin natin is i-integrate natin bawat terms. Okay, so ibig sabihin, integrate natin si first term na e to the x, i-integrate din natin ng separate si 2 to the power of x dx. So saka na natin i-add yung result sa final answer. Okay, so eto, pwede natin siyang ma-rewrite as the integral of e to the power of x dx plus, kasi plus yan, integral of 2 to the power of x dx. Okay, so ibig sabihin, eto siya, i-apply natin yung theorem A. Etong theorem A, di ba ang integral niya is e to the power of x. So that's why, eto siya, ang integral niya, eto is naging e to the power of x. And then, eto namang pangalawang term, integral of 2 to the power of x dx. Ang integral niya is using the theorem B. Okay, so di ba ang sabi ko dito a is, where a here is a constant. So ibig sabihin, kung ang base natin is a constant number, tapos ang exponent niya is the variable x, ang ifa-follow natin na integration or formula is yung sa theorem B. So ibig sabihin, follow lang natin yun, di ba? A ito, so i-replace natin yan by 2, so that's why 2 to the power of x, since ang a natin dito class is equal to 2. So ibig sabihin, lahat ng a dito is papalitan natin kung ano yung given dito na constant. Okay, so 2 to the power of x over the ln of 2. Kasi di ba yun, ln of a. So si a, pinalitan lang siya ng 2. Okay, so next example tayo. The integral of 3 to the power of x dx. So eto siya, obvious na obvious. Parehas siya doon sa theorem B natin na integral of a to the x dx. So ibig sabihin, eto yung gagamitin natin na formula for example B. Okay, so ang a natin dito class is si 3. Okay, and then di ba ang formula doon kanina is a to the power of x over the ln of a. So ibig sabihin, si a dito, papalitan natin siya ng 3, and then si a din dito sa baba, sa denominator is replace natin siya by 3. So that's why ang naging integral ni 3 to the power of x is equal to 3 raised to the power of x over the ln of 3 plus the constant c. Okay, take note, yung i-add ninyo na c is dapat, it should be in capital letter. Okay, so another example pa rin doon sa theorem 1.2.2. Dito nga lang sa example na to is gagamitin na natin or apply na natin dito yung chain rule. Okay, yung chain rule is may integrate natin yung given integrand by using or by letting variable u. Okay, for example, Ito, evaluate the indefinite integral 10x raised to the power of 3 over x raised to the power of negative 2 dx. Okay, etong x cubed na yan class is exponent yan ni 10 ha. And then, ang exponent din dito ni x is si negative 2. Okay, so para madali natin siyang ma-integrate, simplify muna natin. So, we have the integral of 10 raised to the power of x cubed. Si x to the negative 2 dito sa given natin, nilagay siya sa taas para maging positive yung exponent niya. So, that's why naging x squared. Tapos si dx, yung dx na yan, andito pa rin siya. Okay, so para ma-integrate natin to, gagamit tayo ng chain rule. Okay, sa chain rule, maglalet tayo ng u. So, di ba ang sabi ko doon sa discussion natin sa chain rule is, ang dapat na ilet ninyo na u is, make it sure na yung derivative niya is andun lang din sa given natin. Okay, so dito, sa given natin, ang ililet natin na u is si x cube. Para ang makuha natin na derivative niya is x squared na lang yung matitira na exponent. So, nandun siya sa given, may x squared tayo sa exponent. Okay, so let u, eto galing dito sa exponent ni 10. So, that's why u is equal to x cube. Ang derivative ni x cube is si 3x squared dx, diba? Sa derivative, ibababa si exponent, tapos saka tayo magma-minus ng 1, that's why naging 2 yan. Tapos, every time na magdi-derive din kayo using the chain rule is dapat, right after ninyong mag-derive, lalagyan ninyo dito ng dx. So, since ang doon lang sa given natin is x squared dx lang man, walang kasamang constant na 3, so i-divide natin to both sides by 3. So divide it both sides by 3, so that's why 3 divided by 3 is equal to 1 na lang, multiplied by this is just equal to x squared dx. So dito sa kabila, naging du over 3 na siya. So ibig sabihin nun, etong si u equals to x cube is papalitan natin yung nasa given natin. And then si x squared dx naman is ipapalit natin dyan is si du over 3. Okay, so di ba ang given natin is ito? So naging ganito na yung form niya kasi di ba si x to the power of 3 dito, ni-replace by variable u kasi yan man yung gilet natin kanina. And then si x squared dx, eto, is ni-replace yan by du over 3. So, eto siya, du over 3. Okay, so since si du over 3, di ba pag walang nakalagay dyan na constant is invisible yan na 1. So, magiging 1 over 3. So, constant na yon. So, kaya siya nilabas dito. So, that's why naging 1 over 3 or 1/3 times the integral of 10 raised to the power of u du. Okay, so this is equal to 1/3. Okay, si 1/3, eto galing dito. So, ayan siya. And then, di ba, eto siya. Okay, take note. Applying the theorem 1.2.2b, okay, 1.2.2b, ang integral nito class, ang a natin dito is 10, 'di ba? And then yung x natin dito is yan si variable u. So that's why ang naging integral nito is 10 raised to the power of u. Ito siya. So ipa-follow natin tong formula na to. Ang a natin dyan is si 10, so that's why 10 raised to the power of u, so u. And then the ln of a, so ang a natin kasi is 10, so ln of 10 plus the constant c. So we have 1/3. So kailangan sa final answer sa chain rule is ibalik natin siya in terms of variable x. So 1/3 times 10 raised to the power of u ni-replace by x cube kasi diba yan yung gilet natin kanina. Ito siya. Over the ln of 10 plus c. So therefore, the integral of 10x cubed over x to the negative 2 dx is equal to 1/3 10 to the power of x cubed over the ln of 10 plus c. Okay, another example doon sa theorem 1.2.2 pa rin tayo using chain rule. Okay, so the same sa previous video natin, using chain rule pa rin tayo. Okay, so ang given natin is a to the power of x ln of x multiplied by the ln of x plus 1 dx. So ang exponent natin dito class is etong x ln of x ha. Okay, so para ma-integrate natin to, gagamitin natin na technique is yung sa chain rule. Okay, so ang ililet natin dito na u is si ln of x. Kaya para ang makuha natin na derivative is si ln of x plus 1. Okay, so take note class, sa chain rule, ang goal natin is dapat yung given natin na integrand is matransform natin in terms of variable u dapat before tayo mag-integrate. And then, ibabalik din natin in terms of variable x, kung variable x man yung original na given na function, kapag sa final answer na tayo. Okay, so using chain rule, so let u is equal to the x ln of x. So, eto siya. So, dinerive ito using the product rule. Okay, so using the product rule. So, ang product rule is, okay, so f prime is equal to u v prime plus v u prime. So, eto yung pattern ng sa product rule. Sa differentiation, ito sa calculus 1. Okay, so derive natin to. Ito yung first function natin and ito yung second function. So we let this one as our variable u and let this one as our variable v. Okay, so first times yung derivative nito, that is 1 over x. Okay, eto ha, etong derivative ni ln x is andun lang siya sa module natin. Okay, sa page 11, if I'm not mistaken. Page 7 ata or 8. Okay. Tapos, plus, kasi di ba plus ito, and then v, ang v natin is si ln x. Etong 1 na to is ito yung derivative ni x. Okay, uulitin ko, si x, galing yan doon. Etong 1 over x na yan is yan yung derivative ni ln of x. Plus, kasi plus man dapat always sa product rule. And then, etong ln of x na yan, galing yan doon sa given natin. And then, yung 1 na yan is yan yung derivative ni x. Tapos, do not forget, pag mag-derive na kayo is lalagyan ninyo ng dx. Okay, so simplify natin to. So, x times 1 over x, cancel out na dito si x. So, that's why naging 1 na lang yung natira sa first term. And then, ln of x times 1 is just equal to the ln of x. Yung dx na yan, galing yan doon. Okay, so substitute na tayo. Pwede na tayong mag-substitute. Ito yung given natin. A raised to the power of x, the ln of x, times the ln of x plus 1 dx. So, ibig sabihin nun, since etong exponent na to is yan yung gilat natin na u, ibig sabihin magiging a to the power of u na yan. And then, etong si ln of x plus 1 dx, di ba yan yung nakuha natin na derivative ni variable u. So, eto siya, di ba? So, eto class, parehas lang dito. So, that's why, eto siya, naging du na din. Okay. So, di ba, eto siya class, doon sa theorem 1.2.2b, yan, eto, integral of a to the u du is equal to a to the power of u over the ln of a. So, yun yung in-apply dito sa integral of a to the u du. So, ang integral niya is equal to a to the power of u over the ln of a plus the constant c. Okay, sa final answer natin, kailangan etong u na to is ibabalik natin siya in terms of variable x. So, a raised to the power of x over the ln of x over the ln of a plus the constant c. So, therefore, ang integral ni a to the power of x ln of x times ln of x plus 1 dx is equal to a raised to the power of x ln of x over the ln of a plus the constant c.
So before tayo mag-proceed doon sa theorems on the anti-differentiation or antiderivative for some trigonometric function, let us recall first the following differentiation formulas of the different trigonometric functions. So ito yung last topic doon sa derivative of a function class, yung derivative of trigonometric function. So, first, ang ibig sabihin lang sa letter A is the derivative of sine is the cosine. Di ba na-mention ko na to doon? If it starts with letter S class, Ibig sabihin, if it starts with letter C, ang derivative niya is always negative. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of secant is sectant. Derivative of cotangent is negative cosecant squared. And then the derivative of cosecant is the negative cosecant and cotangent and cosecant. So, ang sabi ko din doon class sa midterm na coverage natin, sa discussion ko doon, ang partner is si sine and cosine, partner din si tangent and secant, tapos si cotangent and si cosecant.
Antiderivatives of trigonometric function. So actually, eto siya is madali lang naman siyang i-familiarize as long as alam na ninyo yung mga derivatives ng some trigonometric functions. So we have 6 trigonometric functions. So eto class is given na to ha. So ibig sabihin, kailangan ninyo itong i-familiarize. Okay, so first one is the integral of the function sin x dx. So, ang integral ni sin x dx is equal to the negative cosine x plus constant c. And then, sa integral of cosine x dx naman is equal to the sin x plus c. Okay, so ibig sabihin, ang partner dito para madali natin siyang matandaan is si sin at saka si cosine. Kung ang tinanong, what is the integral of sin? Okay, that is the negative cosine. Okay, and then kung ano yung integral ni sin, cosine is ang integral niya is si sin x plus the constant c. Okay, the third one is the integral of secant squared x dx is equal to tangent x. Okay, secant squared ha, remember the exponent here. Secant squared, ang integral niya is si tangent. Ang integral naman is secant x, tangent x dx, or pwede natin itong mabaliktad as tangent x, secant x. Parehas lang yun ha, is equal to the secant x. Okay? So, which means, ang partner din dito class is si secant at saka si tangent. Pag nakita din yung secant squared, may exponent, ibig sabihin nun, ang integral niya is si tangent. Kapag pinag-combine naman si secant and tangent, ang integral niya is si secant x plus the constant c. Okay, the fifth one is the integral of cosecant squared x dx. So, cosecant squared x dx is equal to the negative of cotangent x plus the constant c. Okay, squared, ibig sabihin nun, cotangent. Sa pang-anim naman is si cosecant x and the cotangent x. Ang integral naman niya is the negative cosecant x dx. So, ibig sabihin, partner din dito si cosecant at saka si cotangent. Kapag ang pinapahanap na integral is yung kay cosecant squared, ibig sabihin nun, ang integral niya is the negative cotangent x. Kapag yung combination naman ng dalawa, ang integral niyan is the negative cosecant x. Okay, so mapapansin ninyo dito class sa theorem 1.3, sa antiderivatives of trigonometric functions, kapag ang result is starts with letter C, di ba eto, cosine, cotangent, and then cosecant is, ang integral nila is always yan negative. Okay, so gito'y tanudan nyo ron. Basta aso result yan, kung after nyo kuhan so integral yan, na mag-starts kayo sa letter C, na always negative so integral yan. Okay? So, basta, ang tandaan nyo lang na technique dito sa pag-familiarize sa antiderivatives of trigonometric functions is si sine and cosine yung partner, si secant at saka si tangent, si cosecant naman at saka si cotangent. Okay, so let's give an example sa trigonometric of antiderivatives of trigonometric functions rather. Okay, for example, first example is the integral of the cosine x minus sine x dx. Okay, so ibig sabihin may minus tayo dito. Ibig sabihin nun, kukunin natin yung integral nito, i-integrate din natin yung second term. Okay, so pag-iwalayin lang natin yan, pwede natin siyang ma-rewrite as the integral of cosine x dx, galing yan doon. Since minus yan, so minus din yung ilalagay natin dito na sine. So, the second term is the sine x, so that's why naging integral of sine x dx. Ito, kumbaga, si integral sine, dinistribute dito sa loob, at the same time, si dx. Okay, so yun nga yung sabi ko doon sa first discussion natin sa anti-differentiation. Si integral na sine is, at saka si dx is hindi talaga yan maghihiwalay. Kailangan kung nandun sa integral sine, andun din si dx. Okay, so dito, so since eto, meron naman to doon sa formula, integral of cosine is si sin x, di ba? Yung sabi ko kanina, partner ni cosine is si sin x. Okay, since minus ito, ilalagay natin dito is minus. And then, integral naman ni sin is si negative cosine x. And then, plus the constant c. So, simplify natin. So, we have sin x plus the cosine x. Kaya niya naging positive kasi negative times negative, that is equal to positive. Okay, so we have constant C. Okay, another example is the integral of cotangent squared x dx. Okay, so eto, gagamit tayo dito ng trigonometric identity kasi di ba eto wala ito doon sa formula. Ang meron lang class sa formula is si cosecant squared x dx. Wala tayong nakita dito na cotangent squared x dx. Okay, so ibig sabihin kailangan natin dito yung knowledge ninyo sa math 112 or sa trigonometry ninyo. Okay, so integral of cotangent squared x dx. So since hindi natin to ma-integrate using the formulas, diretso, what I mean is, hindi natin to ma-integrate diretso using the formulas kasi wala to doon sa formula. Okay lang sana kung ang doon. Okay, so eto, di ba ang equivalent ni cotangent squared x is equal to the cosecant squared x minus 1. So, kailangan natin to. This is one of the trigonometric identity. Okay, so ibig sabihin nun, before natin to ma-integrate, kailangan ma-transform muna natin into this form. Okay, so eto siya. Ito yung given natin, naging cosecant squared x minus 1 siya kasi di ba ito, equivalent lang siya dito. Ayun, galing doon sa taas. Okay, so pwede na natin itong ma-integrate kasi di ba si cosecant squared x, meron siya doon sa formula natin. Ito siya. Okay. So, cosecant squared x dx, pinaghiwalay muna natin to, integrate natin to, first term, integrate din natin si second term. So, we have the integral of cosecant squared x dx minus, di ba may 1 tayo doon, minus the integral of 1 dx. So, cosecant squared x dx, doon sa formula natin, eto siya, ang integral niya is the negative cotangent x plus c. So, eto siya, ang integral ni cosecant squared x is the negative cotangent x minus x. Kasi di ba doon sa theorems of anti-differentiation, the integral of dx is equal to x plus the constant c. So, that's why, eto, yan yung integral ni 1 dx. Another example sa theorems sa antiderivatives of trigonometric functions. So, eto, ang ginamit dito class na variable is the variable v. Kung variable v yung ginamit dito, ibig sabihin v din yung ilalagay natin dito after the d. Hindi always dx ha. Depende sa ginamit dito na variable. Kung ang ginamit dito na variable is y, of course, it follows also na ang maisusulat dito or magagamit natin dito na variable is dy din siya. Okay, so parehas doon sa, okay, the same doon sa previous example natin, si cotangent squared. Si tangent squared din, di ba wala din yan doon sa formula natin? Wala kayong nakikitang tangent squared. So, ibig sabihin nun, ma-integrate lang natin to by converting this integrand into its equivalent. Okay, so using the trigonometric identity, tangent squared v is equal to secant squared v minus 1. So, ibig sabihin nun, etong si tangent squared v is equivalent siya as the secant squared v minus 1 according to the trigonometric identity. Okay, tapos dv. So, di ba, eto siya, pwede nating ma-rewrite as the integral of secant squared dv. Integrate din natin si 1, second term na 1. So, that's why minus, kasi minus yung nandoon. Integral of 1 dv. So, eto siya, okay na, kasi di ba may integral of secant squared man tayo, yung sa pangatlo. So, ang integral ni secant squared dx is equal to the tangent x. So, it implies that the integral of secant squared b is equal to tangent v. And then, the integral of 1 dv is equal to v plus c. So, therefore, the integral of tangent squared v dv is equal to tangent v minus v plus c. Okay? Next example is the integral of sine over cosine squared x. Ibig sabihin, dalawa yung cosine natin dito kasi cosine squared man. So, before natin ito ma-integrate, is simplify muna natin siya. Simplify muna natin. So, eto, pwede natin itong masulat or ma-express as sine over cosine times 1 over cosine. Kasi di ba sine x times 1, babalik siya doon kay sine x. Cosine x times cosine x is babalik siya doon kay cosine squared x. Tapos, dx. Okay, so take note class, take note, si sine x over x is equivalent to tangent x. And then also, si 1 over cosine x is equivalent siya kay secant x. So, which means, dito sa given natin, si sin x cosine x rather is papalitan natin yan ng tangent kasi yun yung equivalent niya. And then si 1 over cosine x naman, ang equivalent niyan is si secant x. Tapos si dx, ayun siya. Or eto siya class, pwede natin siyang masulat as secant x tangent x dx. So, di ba eto, andun to sa formula natin, formula number 4, the integral of secant x tangent x is equal to the secant x plus the constant c. So, etong secant x na to, yan yung integral ni secant x tangent x dx. Okay, another example, gagamit tayo dito ng chain rule or gagamitin natin dito na technique is the chain rule. Katulad nung kanina sa exponential and logarithmic functions, nagamit din natin doon or na-apply natin doon si chain rule. Okay, so ba-apply din natin si chain rule kay trigonometric function. So say for instance, ang given natin na integrand is sine 5x. Okay, so of course, sa unang tingin ninyo, akala ninyo, diretso na itong i-integrate using the formulas on antiderivatives of trigonometric function. No, class. Kapag ang angle natin dito is hindi na siya variable x kasi may kasama na siyang constant na greater than 1 or not equal to 1, is hindi tayo allowed na gamitin diretso yung formula ni sin x dx. Unless na lang class, kung ang given is sin tapos x dx, of course, diretso na natin kukunin yung integration niyan. Gagamitin natin yung formula doon sa theorem 1.1.3 na this is equal to negative cosine x plus the constant c. Since ang constant dito is not equal to 1 man, that is equal to 5. So, ibig sabihin nun na basta lagi di may niyo na kagamitan nyo ay sa chain rule. Okay, so gina na angle saya na basta greater than, what I mean is hindi na siya equal sa 1 is ililet nyo yan as your variable u. So, let u is equal to 5x. Ang derivative ni 5x is 5dx, diba? Okay, so divide tayo both sides by 5. Okay, so naging du over 5. So which means, ang i-replace natin dito kay dx class is si du over 5. Ang i-replace natin dito kay 5x is the variable u. So that's why naging ganito siya. Integral of sin u, yung u na yan yung 5x, and then du over 5 is yan yung pinalitan na si dx. So, since may constant tayo dito na 1 over 5, so, nilabas natin siya sa integral sign. So, we left with sin u du. Okay, so since, di ba, mapapansin ninyo dito, variable u na lang ito, wala siyang kasama dito na constant na hindi 1. Hindi katulad dito kanina na 5, di ba? So, kapag ganito na yung nangyari, is pwede na natin gamitin yung formula na integral of sin x dx is equal to the negative cosine x plus c. So, it implies that integral of sin u du is equal to the negative cosine u plus the constant c. Okay, and then, si negative nandyan man, so ilabas natin dito, so magiging negative times 1 over 5, that's why naging negative 1 over 5, and then cosine, si u, ibabalik natin siya kay 5x. Di ba yun man yung sabi ko sa chain rule, kailangan in final answer, balik natin in terms of variable x plus the constant c. Okay, another example, chain rule pa rin tayo. Okay, so ang given natin is the integral of secant x minus 1, tangent of x minus 1 dx. Okay, so di ba meron tayo doon sa formula natin is secant x lang siya. Ang variable lang doon or ang angle lang natin doon is x. Okay, hindi x minus 1. Okay, so ibig sabihin nun, para magamit natin yung formula na yun, ililet muna natin to as our variable u. So let u is equal to x minus 1. Ang derivative ni x minus 1 is just dx. Kasi di ba derivative ni x is 1 times dx, that is equal to dx pa rin. And then derivative of a constant 1 is 0 naman siya. So that's why dx na lang ito. Okay, so ibig sabihin nun, si secant x minus 1 tangent x minus 1 dx is naging integral of secant u. Eto siya, pinalitan yung x minus 1 dito. And then, si tangent u naman dito, yan, is pinalitan yung x minus 1 dito. So, that's why naging integral of secant u, tangent u, du. So, eto, since ang variable na natin dito or ang angle na natin dito is only a variable, wala siyang kasamang constant maliban sa 1, is pwede na natin gamitin or i-apply yung formula doon sa theorems on antiderivatives of trigonometric function. So, di ba, ang integral nito class is just the secant. Okay, so since variable u yung nandiyan, it follows also na variable u din yung ilalagay natin dito. And then, sa final answer, kailangan ibalik natin siya into its original form. So, magiging secant of x minus 1 plus c. Because u is, that is our x minus 1. Yan yung gilet natin. Okay, so last example sa antiderivatives of trigonometric function. Ang given natin is the integral of x squared secant squared of 4x cubed dx. Okay, so ibig sabihin ang angle dito ni secant squared is si 4x cube. Okay, so di ba? Ang meron lang kasi doon sa formula natin sa theorems on antidifferentiations or antiderivatives of trigonometric function is secant squared x lang. Okay, secant squared x. Kaso dito, naging secant squared of 4x cube. Okay, so integrate natin to, katulad doon sa previous video natin is gagamitin natin dito yung chain rule. So, let natin to as our variable u kasi pag i-derive na natin to, eto yung lalabas, di ba? Si x squared. Hindi natin pwedeng i-let as u si x squared kasi ang magiging derivative ni x squared is wala dito sa given natin. So, take note, ang ayabo ipaglet iwayu na kailangan na so derivative yan, make it sure so derivative yan na duduro o bumambu si ko given niyo. Kailangan tano kasi sa chain rule na kasambihan tano langon so original tano wag given na beloy tano na langon na variable u. Okay, take note din, kapag trigonometric na yung pinag-uusapan na kanaba nyo ipaglet u, so trigonometry. Kasi trigonometry na as is lang yan. Okay. Ayaw mo ipaglet u, ayaw mo kaalin sa anap kasambihan sa variable u na subuso, angle yan. Gini pagmin na ka na angle. So, variable after ko trigo. Okay. So, let u is equal to 4x cubed. So, ito siya. So, 4x cubed. Ang derivative ni 4x cubed is si 12x squared dx. So, para ma-factor out na natin yung constant. So, divide our both sides by 12, du over 12. So, that's why naging du over 12 is equal to x squared dx. Okay. So, it implies that eto is, di ba pwede natin itong ma-rewrite class as secant squared of 4x cubed x squared dx. Okay, si x squared dito sa original function, nilagay ko lang dito sa tabi ni dx para mas madali natin ma-change or ma-determine yung pag-change natin. Okay, so sa secant squared pa rin yan. Si 4x cubed, yan yung papalitan natin ng variable u. Okay, so ayan siya. And then si x squared dx naman, i-replace natin yan by du over 12. Okay, galing doon ha, galing dito. Okay, ayun si u, ayun si du over 12. Okay, so So, second squared, since may constant tayo dito na 1 over 12, so ilabas natin si 1 over 12. So, we left with second squared du. So, eto, nandun to sa formula. Second squared x, and ang integral niya is si tangent x dx, di ba? At tangent x plus the constant c. Okay, so ang integral, si 1 over 12, eto siya, bring down lang. And then, integral nito, si second squared is si tangent u plus c. Okay, and then, 1 over 12, okay, sa final answer natin dapat, si u is, ibabalik natin yan into variable x. So, that's why we have 1 over 12 tangent 4x cubed plus c.
Let's proceed sa definite integral. Sa definite integral class, ibig sabihin nun, fix na yung makukuha natin dito na result. Ibig sabihin, may makukuha na tayo na number. Unlike kasi doon sa previous discussion natin sa anti-differentiation is, ang tawag doon class sa lahat ng binigay ko na examples is indefinite integral, which means hindi fix or hindi constant yung na-obtain natin na result, kundi function pa rin. Pero dito sa definite integral, constant na yung ma-obtain natin right after nating mag-evaluate ng integrand natin. The definition of the definite integral is the definite integral of f from a to b. It is denoted by the integral of f of x dx. Ito yung integrand natin, dx. And then, naidagdag dito sa definite integral is may limit na siya. It is evaluated from a to b. In the notation for the integral class, f of x is called the integrand and a is the lower limit. Ito siya. And then b is the upper limit. And the symbol integral is called the integral sign. So, ito yung tinatawag natin na integral sign. The symbol integral aptly resembles the letter S since the definite integral is the limit of the Riemann sum. We have the properties of the definite integral class. If a function f is integrable on the closed interval ab and c is any constant, then the integral of f of c times f of x dx evaluated from a to b is just equivalent to c times the integral of f of x dx evaluated from a to b. Okay, ang ibig sabihin lang nito, katulad nung sa properties or sa theorems on anti-differentiation, pag may constant sa integrand natin, pwede natin siyang ilabas sa integral sign. If the function f and g are integrable on the closed interval ab, then the integral of f of x dx, f of x plus g of x dx, evaluated from a to b can be written as in this form. So, ibig sabihin lang nito class, integrate natin to. Pag-integrate yung so bawat terms saya. Gito'y pagminsagay kadua properties of the definite integral. Before ako magbigay ng examples sa definite integrals class, let's discuss first the evaluation of definite integral. So, Theorem 9.5.1, the first fundamental theorem of calculus or that is what we call the FOTC. Suppose that f is a continuous function and that f prime is integrable on the closed interval ab, then the integral of f prime of x dx evaluated from a to b is equal to f of b minus f of a. Ang ibig sabihin lang nito, pag na-integrate na natin siya, yung integral natin, ipag-evaluate tanus kaniyan, ikidiyong ko na, ipag-substitute tano ron sa upper limit minus yung lower limit. Take note class, the expression f of b minus f of a in this equation may also be indicated by the shorter notations. F of x evaluated from a to b or f of x evaluated from a to b. Parehas lang. Pag nakita ninyong ganito, the same lang yan. The FOTC or the first fundamental theorem of calculus states that if f is integrable function in AB, the closed interval AB, then we may compute the definite integral f of x dx evaluated from a to b by using the steps below. So, step 1, find any antiderivative f of x of capital letter f of x. This means that f prime of x is equal to f of x. Sa step 2, pag nakuha nyo na yung antiderivative ng integrand natin, evaluate f of b and f of a. Sa step 3, subtract f of b minus f of a, and then the difference is the value of the definite integral. Sa next slide, class, is magbibigay na tayo ng example sa the evaluation of the definite integral.
Example, so first step is, before tayo mag-evaluate, ibig sabihin before natin gagalawin yung limit na yan, ang tawag dito is the upper limit and then the lower limit. Okay, so remember ha, si B is our upper limit. Okay, this is our upper limit, and then si A naman, ang tawag natin dito is si A naman, ang tawag natin dyan is si lower limit. Okay, so before natin i-evaluate yung limit ng given natin na function is, i-integrate muna natin siya. Ibig sabihin no na kusar tanwa doon, so yaswa tano si ko paganay lecture tano si ko chapter 1 anti-differentiation. So di ba ang usual na integration is mag-a-add lang tayo ng exponent. Mag-a-add lang tayo ng 1 sa exponent and then bring down natin siya sa denominator. Okay, so for example, so we have the integral of x cubed dx. It is evaluated from 3 to 1. From 1 up to 3. Okay, so it is evaluated from 1 up to 3. Okay, so ang gagawin natin dito, i-integrate muna natin to. Ibig sabihin, magiging integral ni x cubed dx is x raised to the power of 4 over 4, diba? Kasi 3 plus 1, and then break down lang natin siya sa denominator. And then, ganito na yung mangyayari sa expression natin. Si 1, lagay natin dito sa baba, and then si 3 naman is doon. Tapos, constant C na yan. Okay. Pero si constant C is matatanggal na yan sa final answer kasi ang mag-obtain kasi natin dito na final answer is constant number naman siya. Okay, so this is equal to, di ba eto siya, pwede natin tong masulat as 1 over 4 x raised to the power of 4 evaluated from 1 to 3 plus the constant C. Okay, mapasadius kanyan ma-integrate, ibig sabihin na miya ka-add ka nun sa exponent, 1 si exponent yan, nagunyubup man pag-evaluate si upper limit ago si lower limit. Aya pag minroo na sige ya na i-substitute yu si ko variable x saya, si kulangon din ng variable x ibarat buaya given tano na polynomial function na langon na variable x ro na sambian niyo kung tunay matatago saya a number sa upper limit ago si ko lower limit. Okay, aya kasway ni nalagi daya 1/4 magiging si 3 is si x, palitan natin yan ng 3 raised to the power of 4. Kaya diba, exponent natin dito is 4. And then, always, ipkidin nyo rin saya na minus. Kasi pag minin saya, ka-evaluate saya na upper limit minus the upper limit minus the lower limit. So, lagi diyan mambu, upper limit minus the lower limit. Ibig sabihin na, pagunan nyo sini mag-substitute na mapasad na minus euro man, nagip man ipag-substitute euro. Tapos nakopya nyo bu ini. So magiging 1 over 4. Diba ang x is papalitan natin yung ng 1 kasi ang lower limit natin is 1. 1 raised to the power of 4. So natanggal na si c. Okay. Di na natin isusulat si C kasi constant lang din naman yung ma-arrive natin dito. So, 1 over 4, si 3 galing yan doon, si 4 is galing doon. Always saya minus ha, and then 1/4 times si 1 galing yan doon, gaya na po si buwanan 1/4 na. Kumbaga na si first term ako sa second term na malagit si Rambo, ugay na si Rambo miya kambida ko pianambian na variable x. Okay, so simplify natin. So 3 raised to the power of 4 is 81 ba? So 81 over 4 minus 1 raised to the power of 4 is 1 pa rin yan kahit ano yung exponent dito. If ang base natin is 1 times 1, that is equal to 1 over 4, diba? This is equal to, so since parehas sila ng denominator, so okay lang yan. So just copy the denominator and then simply subtract the numerator. So 81 minus 1, that is equal to 80. Okay, so 80 divided by 4, pwede pa yung masimplify. So the lowest term is, what will be the lowest term? 20. Okay, so this is equal to 20. So therefore, the integral of x cubed dx evaluated from 1 to 3, is equal to 20.
In this example class, evaluate the integral of x cubed plus 3x minus 1 dx integrated from negative 2 to 5. So, ibig sabihin, ang limit natin dito is negative 2 and 5. 5 is the upper limit and then negative 2 is the lower limit. So, solve natin to for the step 1 ay sabi niya, find the antiderivative of the integrand. So, ang integrand ni x cubed plus 3x minus 1 is, okay, so mag-add tayo ng 1 sa exponent. So, magiging 3 plus 1 is 4 over 4. Bring down lang natin sa denominator yung exponent. Plus 3x to the power of 1 plus 1 is 2 over 2 minus constant man si 1. So, ang sabi ko, pag may constant sa function natin, to get the antiderivative, just simply add a variable. Okay, kung 5 yan, magiging 5x plus the constant c. As explained in remark 2, or in the previous remarks sa previous slide natin, we may omit the constant of integration in the evaluation of the given definite integral. Okay, saya class sa definite integral, namin ko pag-integrate ka no din na, ipag-omit yun din sa constancy. Unlike kasi ro sa indefinite integral na always anak constant si po final answer ka. No, nasaya sa definite integral na ipag-omit tayo ron din kasi saya tano bukas ikakuha ang result saya sa definite integral na always constant. Thus, okay, ang integral nito is x to the 4 over 4 plus 3 over 2x squared minus x. It is evaluated from negative 2 to 5. So, ang gagawin natin dito, si 5, yun yung unahin nating i-substitute sa lahat ng variable x dito. So, we have replace x by 5. So, magiging 5 raised to the power of 4 over 4. Sa second term, magiging 3 over 2. Replace si x ng 5 raised to 2 minus 5. And then minus, always itong minus. Okay? So, negative 2, i-replace natin dito sa x. So, magiging negative 2 raised to 4 over 4 plus 3 halves times negative 2 quantity squared minus, okay, may negative 2 dito. Okay, so kung i-simplify natin to class, we have 723 over 4. So this is for the evaluation of the definite integrals.